Tonight's presentation is titled Know Your Oleo. And our presenter is Mike Bush. Mike is president of Savvy Aircraft Maintenance Management. He holds a CFI certificate and A&P mechanic certificate with IA authorization. He's an author for numerous aviation publications. And in 2008, he was awarded the Aviation Maintenance Technician of the Year by the FAA. Mike's also a member of the EAA. Mike, thank you so much for being with us tonight and sharing information about Oleos. I'm going to turn control of the presentation over to you.
Okay, Tim, and good evening, everybody. I have to say I'm really impressed. We have something like 300 people in the room, and for a webinar that probably has the geekiest title of anything I've ever done, I guess this is the 51st in my series of EAA webinars. But you've got to be a dyed-in-the-wool geek to come to a webinar called Know Your Oleo. Actually, I think you'll find it kind of interesting, but I'm impressed that we have the turnout that we do tonight. So anyway, what we're going to be talking about tonight is landing gear. And you know, if every one of our landings was a greaser that just barely kissed the runway, and if every runway that we landed on was billiard table smooth, then landing gear would be really simple. Our aircraft could have landing gear like this, like a little red wagon or a pair of roller skates or a tricycle. But in the real world, of course, runways aren't always pool table smooth, and some of our landings are a bit on the firm side. So nearly every airplane ever built has a shock-absorbing landing gear of some kind or another. And there are a number of different designs for shock-absorbing landing gears for airplanes. Lightweight airplanes often can get away with a simple bungee cord shock absorber like this J3 Cub, where it's got landing gear legs that hinge, and it's got elastic shock cords to absorb the impact of landing. Very simple scheme, and it works pretty well for very small, very light aircraft. Getting a little bit bigger, where the bungee cords are pushing their limit, a number of aircraft, including this Mooney and actually the nose gear of some other aircraft like a Cirrus, use a stack of rubber donuts to perform pretty much the same function that the bungee cords do. Again, it's a spring that absorbs landing impact. Another design is the Whitman gear that was developed by Air Racer Steve Whitman, well known to all EAA members. It was developed by him in the 1930s and actually licensed by Cessna. Whitman patented this gear design, and Cessna licensed it in the 40s, and has basically used Whitman spring steel gear legs on pretty much every single engine airplane they've ever built, if we don't include the new Cessna 400, which is really a Columbia with a Cessna logo on it. But at any rate, again, this is a very simple landing gear design that is based on a spring, and in this case, the landing gear leg itself is the spring that absorbs landing impact. And even if we look at a modern design aircraft like the Cirrus SR-22, the main gear of the SR-22 is basically a Whitman gear, except that the leg, instead of being made out of spring steel, is made out of composite. But the principle is exactly the same. Now, all of these simple springy gear designs, if I can call them that, have some compelling advantages. They're cheap, They're lightweight, they don't have very many parts, and for all intents and purposes, they're maintenance-free. Not completely. The bungee-style gears, occasionally the bungee cords need to be replaced. Rubber donut gears, occasionally the donuts have to be replaced. The Whitman gear pretty much is totally maintenance-free. But these springy gear designs have two serious disadvantages. First of all, they don't scale well to larger aircraft. If the aircraft gets big enough, the size of the springs that are needed to absorb the landing impact get impractically large and heavy. And second, and probably most important, springy gears are springy. They don't damp recoil very well. So with a springy gear design, the harder the landing, the more energy the gear spring absorbs, and the more energetic the recoil. And the result is that unless you make a nice smooth landing with a springy gear, you're likely to bounce right back up into the air. And we know what happens when that happens. At best, we have a multiple landing attempt on a single roll, and frequently we wind up with pilot-induced oscillations that sometimes can cause loss of control or damage to the aircraft. You know, an example of this, if you want to look way back, is the New York to Paris Ryan airplane that Charles Lindbergh flew. And this airplane was a Ryan M2 mail plane that was modified so that it could lift 450 gallons of fuel and have a maximum gross takeoff weight of 5,250 pounds, which was about twice what the normal Ryan M2 mail plane could handle. So they had to really beef up the landing gear in order to support this weight. And anybody that has ever seen the old motion picture photos of particularly of Lindbergh's takeoff from Roosevelt Field, and to a lesser extent his landing at Le Bourget in Paris, know that they weren't very elegant. There was a tremendous amount of bouncing, and in fact the takeoff had so much PIO on it that it came very close to ending in disaster. So this airplane with a gross weight of 5,250 pounds, which is almost as much as my Cessna 310 twin weighs, is really too big an aircraft to use a simple spring gear like this. The solution to this problem was introduced in the late 20s by a company called the Cleveland Pneumatic Tool Company, a company that nowadays is a Cleveland Wheel and Brake. And what they introduced is what was called the Oleo pneumatic or air oil shock strut. They introduced it under the trade name Aerol, which I guess is short for air and oil. And it had significant advantages over these simple spring-style gears, and quickly caught on during the 30s, and by the time the 40s came around and we got into the business of building all these warbirds, the Oleo pneumatic strut, or Oleo for short, became the landing gear design of choice for the warbirds of World War II. And it's been used ever since on airplanes of all sorts of different sizes. Here's an example of the left picture is a main gear on a warbird. The right is the nose gear on a Bonanza. And oh, by the way, unlike the springy gears, the Oleo Oleo strut scales well to larger aircraft. This is about the biggest I've ever seen. At any rate, let's talk about how these Oleos work, because they're actually pretty clever in design. The basic idea is that instead of a mechanical spring or elastomeric spring, the Oleo uses compressed gas as its spring, and it basically consists of a pair of telescoping tubes that create a variable displacement cylinder and are partially filled with hydraulic fluid and partially filled with gas, typically either compressed air or compressed nitrogen. And these two telescoping tubes, as I said, create a variable displacement chamber where the gas is acting as a spring. The fluid is incompressible. So as the strut during landing goes from fully extended to fully compressed, the volume of the fluid stays the same, but the volume of the gas gets less and less, and the pressure of the gas gets higher and higher. And so essentially you're compressing this gaseous spring. Now, when we talk about this, and I'm going to be doing this, referencing this quite a few times as we proceed, we're interested in basically three benchmark states of the strut. The left one is fully extended. That is when there's no weight on the wheel, and as if let's say the airplane's in flight and coming in for landing. The strut is fully extended. The middle one is called the static position, and that's where the basic weight of the airplane is on the strut and is compressing the gas at basically the amount of pressure that the aircraft's weight puts on the strut. We'll be talking about this a little bit more. And then the right hand is the fully compressed state of the strut, which is basically what would happen if the strut was being subjected to a hard landing. The FARs require that the aircraft can survive a pretty hard landing without anything bad happening to it. And for aircraft of the size that most of us fly, we're talking about impacting the runway at something like 600 feet a minute, i.e. forgetting to flare, and a deceleration by the landing gear of something like 3 Gs. That's what we call an arrival. So anyway, keep in mind that we're going to be looking at the state of this strut in these three positions: fully extended, where there's no weight on the wheels; static weight, which is basically the weight of the aircraft on the wheel, just as if you were taxiing around; and fully compressed, which is what happens on impact on a hard landing. The maximum weight that the strut is designed to carry. So we talked that the function of the air or the nitrogen, the gas part of the strut, is basically a spring. But the secret of the Oleo is in the oil part, the hydraulic fluid. And the purpose of the fluid in the strut is to damp the action of the spring and to slow the rate at which the strut absorbs landing shock and to reduce the post-impact recoil. And by doing that, by damping the action of the strut, something that simple spring landing gear designs can't do, the Oleo minimizes the chance of a bounced landing. Now, in order to do this, the Oleo has a fairly clever design. In the fluid chamber, or the fluid portion of the strut, there is an orifice plate. It's basically a disc with a calibrated hole in the middle. And when the strut compresses, the fluid in the lower part of the strut is forced to move through this orifice into the upper part above the orifice plate. And conversely, when the strut extends again, the fluid is forced to go the other way, down through the orifice into the lower part of the strut. And the size of that orifice controls how much damping there is in the action of the strut. The smaller the orifice through which the fluid has to pass, the stiffer the strut and the more reluctant it is to move. Now, inside this, the hole in the orifice plate is a tapered metering pin whose diameter continuously changes, so that the pin is skinny and the orifice is large when the strut is fully extended. And then as the strut compresses and the metering pin moves further and further through the orifice plate, the size of the resulting orifice gets smaller and smaller and restricts the motion of the fluid more and more, until with the strut fully extended, the orifice is essentially almost all the way shut. So the orifice plate divides the Oleo's fluid chamber into two sections. On landing, the fluid is forced from the lower section up through the orifice to the upper section. During recoil, the fluid is forced back in the opposite direction. And the smaller the orifice, the stiffer the strut and the greater the action of the strut is damped. Okay, so I think we've gone over all of this. So what happens is that when you come in for a landing and you start off with a fully extended strut, the metering pin is skinny, the orifice is pretty big, and so the strut starts off very soft. And then as the strut compresses more and more, and a larger and larger diameter portion of the metering pin is in the orifice, the strut gets increasingly stiff and damps the action more and more. And then if the landing is hard and the strut wants to recoil, in its compressed state, it's highly damped, and so the recoil is very slow. And then as the strut extends again, it gets less and less stiff. So it's really a pretty clever system. Now, let's talk about how one would design an Oleo. It's kind of interesting. It helps you understand the principles involved. Some of you guys may be home builders that might be interested in designing an Oleo. Most of you probably aren't. You either have an airplane with one of these struts, or you would buy a commercial one and you'd leave the design to somebody else. But it's kind of interesting to go through the basic guidelines of how you would design one of these things, because it helps to understand how they work a little bit better. So let's take, for example, the main struts for my airplane, which is a Cessna 310, weighs about 5,500 pounds maximum gross takeoff weight, just a little bit heavier than Lindbergh's airplane was. And because the airplane is 5,500 pounds and it's a tricycle gear airplane, each main strut needs to support a little bit less than half the weight of the airplane, roughly 2,500 pounds, with the nose gear supporting a little bit. So we'll say the nose gear supports 500 pounds, and the remaining 5,000 pounds is split between the two mains. So each main needs to support about 2,500 pounds. That's with the airplane static, just sitting on its wheels or taxiing around. And we in the previous diagram I showed that the static pressure in the strut when the airplane is weight on the wheels is 1,200 psi. We'll see how we got to that shortly. But if it's 1,200 psi supporting 2,500 pounds, then we can calculate very easily what the size of the strut is, what the cross section is, and it needs to be a little bit over 2 square inches. So the piston diameter would be about 1.7 inches. Let me just, for just a second, because somehow or other we skipped ahead on these slides. I need to back up because I was seeing that that we were missing some stuff here. Okay, let me start back here. I'm sorry, guys. Somehow we got the same problem here. I don't know why. There's some stuff that I'm seeing on my previous slides that's not showing up on the screen. Anyhow, let me sort of fill in what this slide's supposed to be showing. As a rule of thumb, the ratio between the pressure in the strut when it's fully extended and when there's weight on the wheels, when it's at its static weight, should be about a 4-to-1 ratio. So this strut has 300 psi when it's fully extended, and it's got 4 times that much pressure when it's got static weight on the wheels, 1,200 psi. The second rule of thumb is that going from the static position to the fully compressed position, that is the maximum load that the strut's designed to handle in the case of a really bad hard landing, should be about a 3-to-1 ratio. So again, if it's 1,200 psi in static position and we slam the thing down on the runway at maximum strut compression, we should have 3 times that much pressure, or 3,600 psi. That 3-to-1 ratio is basically comes from the certification requirements of how hard a landing the FAA requires. And again, there's some stuff that's missing on this slide. A couple of other guidelines is that when we're designing the pressures for this strut, we don't want the fully extended pressure, which is the minimum pressure, to be less than about 50 or 60 psi, because it needs at least 50 or 60 psi for the seals that seal the inner tube to the outer tube. And then there's a series of seals, either O-rings or slightly more complicated seals than that. But they need a minimum of 50 or 60 psi for those seals to seal up nice and tight to the inner tube of the strut. On the other end of the scale, we don't want the pressure ever to get higher than about 5,000 or 6,000 psi, because that's the most pressure that an O-ring seal is going to be able to tolerate without the possibility of it blowing out. So we have a couple of kind of practical constraints. And finally, when the strut is in its static position, we don't want the pressure, if possible, we don't want the pressure to be higher than about 1,800 psi, simply because that's as much pressure as you can typically get out of a nitrogen cylinder. And so if the strut requires more than 1,800 psi with weight on the wheels, then we couldn't air up the strut without jacking the airplane off the ground. So we have a few practical considerations for how we want these pressures to come out. And this particular design that I'm showing you here, which is the strut on my Cessna 310, clearly meets all those constraints. The minimum pressure is well over 50 or 60 psi. The maximum pressure is well under 6,000. And the static pressure is well under 1,800. So it meets all of those design criteria. The main gear strut on my Cessna 310, when the airplane's up on jacks or when it's flying, the strut extends to about 12 inches in length. So if there's a 4-to-1 compression ratio, which is what we said our design goal is, going from unloaded to static, then the strut should compress to about 3 inches when the airplane's weight is on the wheels. And under a maximal hard landing, where the compression ratio is another 3-to-1 from static to maximum compression, the strut would compress all the way down to about 1 inch at the maximum impact that the strut would handle in a maximally hard landing, which is a 3G impact, a 600 foot per minute descent right into the runway. Nose gear handles much less weight. It has a shorter throw, much lower working pressures. In my airplane, the max nose strut extension is only about 6 inches, about half as long as the main struts. The unloaded pressure is right down at the minimum, about 50 psi. Static pressure is about 200 psi, and the strut at 200 psi is extended to about 1.5 inches, about a 4-to-1 ratio again. But although the nose gear handles a lot less weight and is much less beefy, its ability to damp recoil is even more important, because in a tricycle gear airplane, the recoil of the nose gear is really a bad thing. If you land the airplane hard and the nose gear recoils, it pitches the nose up, increases the wing angle of attack, and makes the airplane want to go fly again. And of course, we know what happens when that happens. The airplane is back in the air. The pilot is trying to recover the botched landing, and this can easily lead to PIO, pitch divergences, that have frequently resulted in wrinkled firewalls and curled prop tips and other expensive things. So the ability to damp recoil on nose gears is particularly important, and that's why, for example, when Cessna designed its first tricycle gear single, which I guess was the 172, it decided, although it was going to use a simple spring Whitman-style gear for the main gear, it opted to use an Oleo for the nose gear, so that it would damp out the nose gear recoil. And Cessna has used that same design ever since, with a Whitman-style springy gear for the mains, but a nice, well-damped Oleo strut for the nose wheel to minimize botched landings. Now let's talk a little bit about maintaining these things. Let's suppose you notice that your Oleo strut extension is a little lower than it's supposed to be. The temptation is to just air up the strut by adding air or nitrogen to bring it back up to the specified height. But before you do that, you want to think for a minute, because a strut that is low could be low either because it doesn't have enough gas pressure in it, or because it doesn't have enough fluid in it. So how do you know whether the strut is low on fluid or low on gas? You know, if your strut is actually low on fluid, and instead you add more gas, basically you make the strut more springy and less damp than it was designed to be. And if you do that enough times, ultimately the strut could wind up just bottoming out on a hard landing, which would be a very bad thing. It could cause serious damage to the airplane. So we want to think about this a little bit. How do you tell whether an Oleo strut that's low needs more air or more oil? Well, the quickest and dirtiest way to figure that out is to rock the airplane. If it's a main gear, rock the wingtip up and down. If it's the nose strut you're looking at, rock the prop up and down, and watch to see what the strut does. If the strut seems excessively bouncy, then it probably needs fluid, because remember, the purpose of the fluid is to damp the action of the strut and to prevent it from being bouncy. On the other hand, if the strut seems stiff and reasonably well damped when you try to bounce it up and down, then all it probably needs is some more air or nitrogen. So before you just blindly add gas to an Oleo strut, try the bounce test and verify in your mind whether the reason the strut is low is because it doesn't have enough gas in it or because it doesn't have enough fluid. Once again, the gas is the spring and the fluid is the damper. And if you understand that, it's usually pretty easy to figure out what the strut needs. Finally, if your Oleo strut starts leaking fluid and you start seeing streaks of hydraulic fluid leaking out on the polished part of the strut, typically these struts use 5606 hydraulic fluid, which is sort of a red sticky stuff. Before you let a mechanic tear the strut apart to reseal it, try adding a bottle of some magic potion called Granville Strut Seal, which you can buy at Aircraft Spruce or other aircraft parts distributors. And Granville Strut Seal is something that's been around for, wow, many, many decades. And it's a magic potion that you add to these struts that cause the seals, the O-rings and stuff, to soften and to swell a bit. And over a period of many decades, I've had an almost perfect batting average of fixing up leaky struts with Granville Strut Seal and not having to pull them apart and change the seals. If the Granville doesn't solve the problem, then you will have to have the strut disassembled and the seals replaced. And as you can see from this exploded diagram, this is a main gear in my Cessna 310. This is the strut. These things are fairly complicated. There's a lot of parts. If you do wind up having a mechanic open up the strut to reseal it, and the seals that are being replaced are the ones that are in the little red trapezoid there. You might want to hang around because it's kind of interesting to see these struts opened up and you wind up seeing the metering pin and the orifice plate and all of that stuff that normally is hidden from view. But again, it's a few hours labor to reseal a strut, and before you do it, my recommendation is to try a little bit of this Granville Strut Seal, which you simply let the gas out of the strut, put the Granville in through the filler valve, and then air the strut back up to its proper extension. And as I said, I've had terrific luck with Granville Strut Seal eliminating strut leaks without having to disassemble the strut and replace all the seals. So anyway, Tim, that's all the prepared stuff I have. We can open it up for questions if you like.
Okay, Mike, great, thank you. Very interesting presentation.
On a very geeky subject.
Yeah, actually, it was riveting though. I really liked it. It was good stuff. You
Well,
don't often get to talk about.
You must rivet easily, Tim.
What can I say? I'm easy. Okay, so let's see. Let's get into our questions here. We got some questions that have already come in. DW just wanted to say that he has used the Granville strut seal. He says it's a miracle in a bottle.
Yes, it is. And there aren't many of those around, but it really works well.
So, question here from Gary. He's just wondering, okay, do you put in nitrogen or air?
Well, nitrogen is always better, both in Oleo struts and in tires and so on. Basically, nitrogen is just air with the oxygen removed, and because oxygen is corrosive, I mean, it's the very definition of corrosive. It's always better to use nitrogen if you can. Now, for large aircraft or really high performance airplanes like business jets and so on, or large aircraft, over 12,500 pounds, typically they will specify specifically that you have to use nitrogen. And the reason is that for large or very high performance aircraft, the gas in the strut heats up so much during landing impact that if there was oxygen in the strut, there is a possibility that the hydraulic fluid could ignite. And so by using nitrogen and making sure there's no oxidizer in the strut, of course, the fluid can't possibly ignite. For smaller airplanes like the one I fly or the one most of you guys probably fly, your choice of air or nitrogen are permitted. If nitrogen is easily available, it's always a better choice. Actually, it's a better choice for two reasons. One, it doesn't have oxygen in it. The other is that nitrogen dispensed from a cylinder, from a gas bottle, is always almost completely dry, whereas air, especially if it comes from shop air, from a compressor, can have a fair amount of moisture in it. And again, you really don't want to be introducing moisture inside this strut because it has the potential for causing internal corrosion. So again, the answer is that nitrogen is always better, and if it's a really high performance or very heavy aircraft, then nitrogen would actually be a requirement.
Question about servicing the oil. Then a couple people have kind of wondered, how much oil do they put in?
That's a great question. And actually, I was actually thinking about doing some slides on that, and then I decided, oh, that's way too geeky. But since somebody asked, the procedure for servicing these struts, let's say you've taken it all apart because you wanted to replace the O-ring, so the strut's got nothing in it. The way you service it, the procedure is this. You open up the filler valve, which is up at the top of the strut, and you hook a length of clear plastic tubing to the filler valve, and you immerse the other end of the clear plastic tubing in a pan full of hydraulic fluid, typically Mill H5606 hydraulic fluid, same stuff that we typically use in brake systems and so on. The airplane is up on jacks at this point, and you manually pump the strut up and down. You compress it and let it extend, and you compress it and let it extend. And each time you compress it, the air in the strut gets ejected and blows bubbles in your pan of oil. And every time you allow the strut to extend, the strut sucks hydraulic fluid into it. And you just keep stroking the strut up and down until it is full of fluid and you're getting little or no air bubbles coming out when you compress the strut, because you want to get rid of any entrapped air. And once you're at that stage, you compress the strut one more time, and then disconnect the plastic tube and hook your nitrogen or air hose to it, and then inflate the strut to the rated pressure. There's actually two ways to inflate a strut. When the strut is when the airplane is on jacks, you inflate the strut to a given pressure. That pressure is always both in the service manual and also is required to be on a placard that is affixed to the outside of the strut that says what pressure it's inflated to. When the airplane has weight on the wheels, you normally inflate it to a given amount of extension. So when you're servicing a strut from scratch, like we're just talking about, you're going to service it to pressure while the airplane's up on jacks, and then after you let the airplane down off jacks and have weight on the wheels, you're going to check that the strut extension is within tolerance. And if it's still a little bit low or a little bit high, you might want to add a little more gas or let a little bit out to get the extension correct. But that's basically the procedure. So the simple answer to the question of how much fluid do you put in is you put in as much fluid as the strut will hold with the strut fully compressed. And it's that simple.
Dwayne is wondering, can you overfill the strut by adding the Granville seal? If so, then what?
Well, again, to add the Granville seal, the very first thing you have to do is jack the airplane, open the filler valve, and let all the gas pressure out. Now you dump the Granville seal into the strut, and you compress and extend the strut a few times to thoroughly mix the Granville with the fluid that's already in the strut. And then the last thing is you fully compress the strut before you start adding gas back in. So if you do it that way, it's not possible to overfill the strut. And again, the only way you can add Granville to a strut is first to let the gas out so that you can put the fluid into the filler valve. So it's kind of a self-correcting problem.
Tom's wondering, is adding the strut seal, the Granville, preventive maintenance that an owner could do?
It is. Actually, if you look at Part 43, Appendix A, and you look at the list of things owners are allowed to do, owners are actually allowed to service the struts with fluid or gas. Now, if you're doing this on a main strut, you need to know what you're doing, because you're dealing with potentially quite a bit of gas pressure. But yeah, basically anything to do with servicing struts, and that would include putting in Granville, which is just kind of a special flavor of hydraulic fluid, is something that a pilot-rated owner is allowed to do without an A&P getting involved.
And Ed's wondering, should the 5606 hydraulic fluid ever be replaced in the struts?
Typically the fluid is normally not replaced except when the strut is disassembled to have the seals replaced. It really is in an application where it isn't getting contaminated and so on, and so I don't think I've never really seen any sort of a maintenance recommendation by anybody to empty struts and refill them with fresh fluid on some sort of a time schedule. But of course, whenever you have to disassemble a strut, and you dump all the old fluid, you would never put it back. You'd always put fresh fluid in.
Kelly says, during takeoff roll, as weight begins to shift from the wheels to the wings, and the struts begin to transition from static to fully extended, my two main struts transition at different times, causing the aircraft to continue the takeoff roll cocked horizontally with one wing higher than the other. Is this normal? And is there anything I should do to fix it?
Was there any mention of what kind of aircraft it was?
No, there isn't.
But I'm assuming it's an aircraft with Oleo struts on both mains, and if they are extending at different rates, the only thing I can think of is that one of them is low on fluid, and so it's not being damped as much as it should as the strut extends. So I guess, I mean, the first thing I would do is resurface the strut and make sure that it has as much fluid in it as it can hold.
Kelly came back and said it's a Piper Warrior.
Yeah. But that's almost the only thing that could cause that is for it to be short on fluid, and somebody sort of made up for it by putting more gas in it to make up for the low fluid, but the fluid quantity is what affects the damping of the strut. So if the strut is low on fluid, then that strut is going to extend faster than it should.
A few people have asked basically the same question, but they're wondering, would you recommend adding the Granville seal to a newly resealed strut, to new seals as a preventive measure, basically?
No, I wouldn't. I would only add it if the steels start to weep.
And Michael's wondering, any words on sticky struts? It says Piper recommends a Teflon release agent spray, but I'd like to hear your thoughts.
Well, I'm not 100% sure what we're talking about with the Teflon release agent spray. The main thing is to make sure that the exposed portion of the strut piston, that is the inner cylinder, the one that's typically shiny and chrome plated, is kept scrupulously clean. A good pre-flight item, or at least something that should be done pretty frequently, is to wipe that exposed strut clean, preferably with a rag with just a little 5606 on it. Because you don't, if there's dirt on that strut, then when the strut compresses, that dirt gets kind of dragged up into the seals and will start deteriorating the seals. So anytime the plane is up on jacks and the weight is off the wheel and the strut's fully extended, the extended part of the strut should be wiped clean. And in fact, pretty much any time you pre-flight it, although not all of the strut is extended at that point, but the part that is should be wiped clean if it doesn't look perfectly clean, because you don't want dirt and grime and grease and stuff to get pulled up into the strut seals and cause them to be damaged.
And a couple people have asked, do you just wipe it and then have it dry, or did I hear you say just a little bit of 5606 on a rag?
Yeah, I always try to wipe it with a rag that has just a little 5606 on it. I don't know if I've ever seen that in a book anywhere, or if it's just my habit. So I don't want to. I won't preach that that's the gospel. That what is the gospel, though, is that it needs to be kept nice and clean.
Sure. Richard's wondering, where do you get the specification for the pressure? He says he had varying answers for a Cessna 182 and a Cessna 150.
The pressure should both be in the aircraft's maintenance manual, and should always be on a placard of some sort of decal or something that's affixed to the outside of the strut. I think that the FARs require, at least for certificated aircraft, that the strut inflation pressure be placarded on the outside of the strut. But it's always going to be the maintenance manual, even if the placard came off and got lost.
Lanny says, I've always kept my 182 nose strut overextended, 4+ inches versus 3 inches in the static position for landing on unimproved grass or dirt strips. Although logical, does this really make any sense?
Well, I mean, I don't think so, because if the strut is serviced properly with the correct amount of air and the correct amount of fluid, it is designed to be able to handle a high impact landing, and I don't think overinflating the strut really helps you. Again, what in a hard landing, what you're really interested in is making sure that the impact is properly damped, and adding more air isn't gonna do that. It's just gonna kind of put the airplane in more of a nose high angle of attack when you're rolling down the runway. So I don't think that overinflating this strut with air accomplishes anything. But what is very important is to make sure that it's full of fluid, because if the fluid is low, then you have the potential that the strut might bottom out on a hard landing, and that would be a bad thing. And 182s are kind of famous for wrinkling firewalls in hard landing situations. So what's important is to make sure that there's plenty of fluid in the strut, not adding additional gas to it.
Robert says, I have a Cessna 152 with a nose strut that slowly collapses. It was rebuilt 2 years ago with new seals and new Schrader valve. We reinflate with compressed air. Should we be using nitrogen to reinflate? I don't see any oil leaking around the strut. Wondering what he should do next. Well,
as I said, nitrogen is always better, but it's not going to prevent leaks. The first thing you need to determine if the strut is slowly collapsing is whether it's leaking fluid out the bottom or whether it's leaking air out the top. And understood that there's a new Schrader valve in there and new seals, but clearly something isn't sealing right. So I think probably the first thing I would do is go up to the top of the strut, especially where the filler valve is, and spray everything down real well with soapy water, and see if you can find anything that's foaming up the soapy water, indicating that there's a slow air leak there. If the absolute worst came to the absolute worst, and hopefully it won't come to this, you might conceivably have to take the strut off the airplane and dunk the whole thing in a tank of water, like, for example, like they do with automobile tires when they're trying to find out where a leak is. But hopefully you don't have to do anything quite that radically. Hopefully you can find it in place using soapy water. But you need to find out where it's leaking, and it clearly has to be leaking, and there's only two places it can leak, up at the top or down at the bottom, and you need to figure out which it is.
Walt's wondering, when an oleo is being compressed, is the energy absorbed dissipated as heat?
Sure. Yeah. I mean, the gas heats up, just like gas always heats up when it gets compressed. That's how diesel engines work, for example, and that's why I mentioned that for really high performance aircraft, the struts need to be filled with nitrogen rather than air, so that even when that gas heats up a lot, there isn't the potential of any sort of combustion, because you've got hydraulic fluid in there that is flammable, but of course it's only flammable if it's in the presence of oxygen. For things like a 182, the air never heats up enough for that to be an issue. But if you're talking about, a Learjet, then the service manual absolutely requires that the strut be serviced with nitrogen for that reason.
And Walt's wondering, do oleos have a bumper to prevent gear damage if it gets compressed beyond full?
No. But again, it should be theoretically impossible for that to happen if the strut is serviced correctly, because as the strut compresses more and more, the gas pressure increases without limit. So like I say, the struts are typically designed so that even under the worst possible impact that the airplane is designed to tolerate in a very hard landing situation, which is really quite impressive, the strut would never compress more than about to 1 inch extension. But no, there's no mechanical bumper in there. There's no rubber or anything like that. It's metal against metal. And if a strut is empty, if there's no air or oil in it, you can compress it and you'll hear it go clunk when it's all the way closed. But when the strut is serviced with air and oil, that shouldn't be possible.
George says, my Cessna 172M has a small nick of sorts on the front of the chrome near the bottom of the strut that appears to be out of the range of the travel of the seals. He says it does not leak. He's wondering, should he address it, or is it okay to keep running it as long as it is, as long as it doesn't leak?
It sort of depends on the position. If the flaw is far enough down that it could not actually engage with the seals with the strut compressed on landing, then probably all you need to do is put a little bit of paint or something in there just to prevent the strut from corroding, because the chrome plating is what normally would prevent it from corroding, but there's apparently a flaw in the chrome, so you'd probably just want to put a little zinc chromate, a little paint in there, maybe epoxy paint or something to protect it. On the other hand, if the position of that flaw is such that it could actually hit the seals on a hard landing, then it probably needs to be dealt with, because for two reasons. One is that on a hard landing, it's conceivable that if that flaw got into the seals, the strut could dump its fluid, and you just haven't made a hard enough landing yet. And the other is that flaw, if it got up into the seals, even if the strut didn't dump its fluid, it could damage the seal because of the roughness. And there are firms that will re-chrome plate those strut pistons. But if it's down far enough that it's never going to get into the seals, then it's probably okay just to put a little corrosion protection over it and live with it, without actually seeing exactly where it is. I can't really make a judgment one way or the other.
We've had a few questions here about atmospheric conditions, changes in temperature, temperature extremes, how that affects the strut performance.
Well, I mean, theoretically, it would affect the strut performance a little bit, but the design parameters that we talked about are so broad that in practicality it really isn't an issue. In other words, you know, if I'm flying my airplane from California to Minnesota in the winter, I may, if I'm smart, add a little extra air to the tires and so on, because I know that the tire pressure is going to be lower up in Minnesota where it's cold, and I know that underinflation of tires is a really big problem. The tires are very sensitive to inflation. But I wouldn't do anything unusual with regard to the strut. That does bring up another thought that I probably should mention, which is that if struts go flat, it usually happens in really cold weather. The cold weather is when we have the most problems with Oleo struts, you know, dumping their fluid and going flat. Primarily because the seals, the O-rings and so on, get really hard and stiff when it's frigid out, and sometimes they stop sealing. So we do tend to get a lot of reports, not a lot, but most of the reports of flat struts that we get typically happen during the winter time.
Michael's wondering, when replacing the internal seals and O-rings, do you lubricate them with anything other than the 5606 prior to reassembly?
Yeah, I mean, typically whenever you put O-rings or that sort of thing in, you use something called Parker O-ring lube, which is an installation lube specifically designed for use on O-rings. I think every A&P has a gnarly looking tube of that stuff in his toolbox, and that's what we always put on the O-rings prior to assembly.
Randy says he has a Cessna 150, and he's wondering, could he use the Granville strut seal in a shimmy dampener as well to soften the seals and keep them from losing fluid?
That's an interesting question. I never heard of anybody using the Granville seal in a shimmy dampener. I can't think of any reason offhand why you couldn't. Again, in a shimmy dampener, I mean, in an Oleo strut, if the seals start leaking, it makes a mess, and you can see it. In a shimmy dampener, normally, at least if the big O-ring, the one around the shimmy dampener piston, starts leaking, you never see it because it's all enclosed in the shimmy dampener. It's not a seal to the outside world. The shimmy dampeners do have small O-rings on both end plates, right where the shaft exits the shimmy dampener. But those are small O-rings, and they usually don't give a lot of problems. But I can't think of any theoretical reason why it would be a bad thing to put Granville strut seal in a shimmy dampener. You wouldn't use very much because the shimmy dampener doesn't hold all that much fluid compared to an Oleo strut, which holds a lot of fluid.
A couple of questions here about the Schrader valve. Bernard's kind of wondering, is the Schrader valve a special high-pressure valve? And David's kind of wondering, can you replace that valve with one that is meant for tires, for example?
There are a bunch of different kinds of filler valves on Oleo struts, and it really varies all over the map. Some of them have cores in them, kind of like tire valves do, and they are actually Schrader valves. And if the filler valve on an Oleo strut has a core, it needs to be a special high pressure core. It can't be a standard tire core. A lot of the filler valves, like the ones on my airplane, don't have any kind of a core. They simply they're a filler tube that's threaded and looks kind of like the filler on a tire, and uses the same sort of cap, but it doesn't have a core inside, and it's got a big hex that you turn with a wrench that opens it or closes it, but it doesn't have a core. So it really depends on what kind of valves installed. Some have cores, some don't. But the ones that do have cores, you couldn't just use a regular tire core because it's not designed for high enough pressure.
We've had a few questions from people who are flying Cherokees who say that they feel like the Oleos are a little sticky, and that's where maybe one will be higher than the other. And they're wondering, overall, is the Granville seal maybe, would that be something that would maybe help lubricate to minimize this stickiness they're talking about?
Well, again, I'm not sure what's causing the stickiness. What the Granville does is it both softens the seals and it causes them to swell a little bit. And whether that would make the stickiness better or worse, I really don't know, because I've not run into that phenomenon, so I can't answer the question.
Okay. Beth was wondering, she says, I was told to clean the strut with a rag with a little gas on it. Is this wise?
Yeah, that's fine. It's fine. The most important thing is that it be kept real clean. And somebody mentioned putting a little Teflon spray on it, and that wouldn't be a bad idea either. I don't know whether the Teflon spray would help with this Cherokee stickiness phenomenon. It's not something I've run into, so I don't know for sure, but it might be worth a try.
Don is
you don't want to spray oil on there, because oil would kind of cause dirt to adhere to it, but a Teflon spray, or something like LPS1, would probably be an okay thing to spray on the strut to see if it helps the stickiness.
Don is asking, if you have a nick in the strut, how do they repair that before they rechrome it?
I don't know. I've never worked in a chrome house, but I assume the nick is in the chrome plating itself. And I don't know exactly what the process is that they use for rechroming these things. I assume they grind the old chrome off and then apply then re-electroplate it back on. But that one's above my pay grade. I don't really know what they do. It's probably one of those they could tell me, but then they'd have to shoot me deals.
Let's not do that. You're too valuable to us here on Wednesday evenings, first Wednesday of the month. I'm sorry. Not allowed. A question here from Melvin about his Cessna 182 and the nose wheel shimmy, and just wondering if you can provide any comment at all about nose wheel shimmy and the Oleo.
I can. The nose wheel shimmy is not an Oleo problem. Let's start with that. But and a lot of people will conclude that when they see nose wheel shimmy, the first thing they'll do is service the shimmy dampener. But typically, the problem of nose wheel, and then there's the other school of thought. I've heard a lot of mechanics that the owner will take a Cessna in and complain about nose wheel shimmy, and they'll say they all do that. You just have to learn to live with it, which is false. The two things that you always want to check when you experience nose wheel shimmy in a Cessna in a single-engine Cessna. The first thing is the condition of the torque link bushings. And again, I don't want to get too geeky, but in any Oleo strut, the bottom portion of the strut and the top portion of the strut are linked together by a pair of arms called torque links that have bushings at the top, the bottom, and at the middle, at the knuckle. These are sometimes called scissors, but the proper term is torque links. Over time, the bushings at the places where those torque links pivot, and again there's three of them, one at the top, one at the bottom, and one at the knuckle joint in the middle, those things wear, and the torque link no longer will hold the bottom and top portions of the strut in perfect alignment. The torque links develop some wiggle. The shimmy damper dampens the movement of the upper strut, but the wheel is connected to the lower strut. So if the torque link has wiggle in it because the bushings are worn, I don't care how good the shimmy dampener is doing its job, the nose wheel will still wiggle because the wiggle is basically slop in these torque links. So the very first suspect anytime a Cessna comes in with intractable nose wheel shimmy is to check the bushings and the torque links, and 85% of the time it turns out that one or more of those bushings is worn. It's a very easy job to replace all the bushings, and then you wind up with a nice tight torque link and all of the shimmy problems go away. The other thing to check when there's intractable nose wheel shimmy is the balance of the nose wheel. If the nose wheel is way out of balance, then when it starts spinning, it'll start shimmying. And probably the best way to do that is to pull the nose wheel off and take it to a motorcycle shop, because motorcycle shops typically have a dynamic balancer that will handle wheels as small as an aircraft nose wheel, whereas automobile places that you typically can't balance a 5 or 6 inch nose wheel on an automotive type balancer, but motorcycle shops typically have equipment that they can do that with. So check the balance and check the torque link bushings, and of course none of this has very much to do with Oleos, but those are the two big culprits when it comes to nose wheel shimmy on Cessnas.
And Terry's wondering, is nitrogen more dense than air, so you would less likely to leak with nitrogen instead of air?
Well, that's a good question. I do think that the nitrogen molecules are a little bit larger than the other components of air, but keep in mind that air is, what is it, 80% nitrogen to begin with. So it's not going to make a huge difference. The biggest reason in small airplanes to prefer nitrogen is to keep moisture from going into the strut and to keep oxygen from going into the strut, both of which could contribute to corrosion internally. But don't expect there to be a big difference using nitrogen as far as whether the strut leaks or not. Nitrogen is better, but not so much for that reason.
Question here, this might be a long shot for you, but Alan says that he has a Cleveland Aerol on a 1933 Stinson SR. He says it's in restoration.
Oh, how cool is that?
Yeah, he says the manual only says add gas until you get 2.5-inch extension.
Uh-huh.
Can't can't figure out the right pressure to use. He says aircraft is on gear but still uncovered.
Well, if the old aircraft like that doesn't specify pressure, then you're just going to have to guess at it, put the airplane down on its feet, and then adjust the pressure to get the proper extension. Most contemporary airplanes, they do provide a specific pressure to use for inflating the struts when the aircraft is not on it, when there's no weight on the wheels. But if you don't have that, then you're going to have to just take a guess and then put it down and see how the extension came out, and then adjust it.
Okay, and maybe this one is related. It's from
I assume that this is probably just the nose wheel, right? That has the Oleo strut on the Stinson, and those nose wheels typically have the strut pressure is typically pretty low, so it's normally quite practical to add or remove gas pressure while there's weight on the wheels. For main gears, it's a little harder to do that, but because the pressure with the weight on the strut tends to be pretty high. But for nose gear, it's not terribly high pressure.
And Archie's got one here. He said, first says great presentation, and wondering if you could discuss struts as his, and you just kind of, I think, touched on it with the Stinson, but he's got a Waco biplane, which has no pre-charge on the gas side. He says his mechanic normally checks the fluid level in the static condition, and he has 0 psi in the static condition. As the strut extends after takeoff, he says the internal pressure must reduce significantly. And just wonder if you can discuss that setup at all. Is the mechanic checking the fluid levels correctly?
I'm lost. I didn't understand it. It can't possibly have 0 pressure, because 0 pressure would be a perfect vacuum. That doesn't make sense. I'm sure that's not what he really meant.
Well, maybe Archie can follow up here if he.
Yeah. By the way, my email address is sitting there on the screen. So if you have an obscure question, feel free to email me. I always try to answer them. Although I have to confess not having any experience with Wacos, so if I can give you an answer, I'll have to work it out from first principles. It won't be for my long years of experience swinging wrenches on Wacos, I can assure you.
Okay, we got one here from Tom. He's got Cessna 310C. He said his strut is leaking fluid from the axle. Somehow it is traveling all the way through to exit there. He says the mechanic has no idea how to fix it. Just wondering if you got a long shot to give to him.
Yeah, well, there's a plug. I actually had a diagram up on the screen of an exploded diagram of the Cessna 310 strut. You can find that in the parts manual, the 310 parts manual. And at the bottom of the lower cylinder, or what's called a piston, but it's the lower tube, the shiny one, there is a plug, fixed plug in the bottom of that thing. It has O-ring around it, and it's held in place with a bolt. And if fluid is getting down to the axle, it must be that O-ring is bad. Now, getting that thing out of there and changing the O-ring is going to be quite a job. It's difficult, and of course the airplane's going to have to go on jacks. The landing gear is going to have to come all apart. And if the mechanic doesn't know what to do with it, you may want to fly the airplane to a Twin Cessna specialty shop that's done this stuff before. I don't know what part of the country he lived in, but there are a number of Twin Cessna specialty shops that this might be worth taking to if the mechanic is in over his head.
All right, Mike. Well, that pretty much wraps up the major content of all the
And again,
questions that have
he
come
can
in.
feel free to drop me an email if he wants specific shop recommendations or something.
Great. All right, sir. Well, thank you so much for a most interesting, nerdy, detailed presentation on Oleos. I think we all got some really good stuff out of it. Thank you so much.
So
Please make
everybody
closing
go out there
comments.
and design an Oleo strut now, right? Okay, Tim. Well, I just wanted to mention upcoming webinars. The first one I think you might have listed on that at the beginning, except that slide went on the screen and off the screen so fast I don't think anybody could read it. But the November webinar is on carbon monoxide, which I think you'll find quite interesting. This is the season for worrying about carbon monoxide because it tends to be the biggest problem during the wintertime, of course. December is another session that's going to be very interesting on piston engine inefficiency. Talks about the fact that our piston aircraft engines only manage to convert about 1/3 of the energy in our $5 avgas into useful work, and 2/3 of that energy just gets thrown away and wasted, and we'll talk about why that is and what things can be done to improve the efficiency of piston aircraft engines. And finally, in January, was a session on the cause of maintenance errors, and basically why humans make mistakes when they're working on aircraft, and what can be done to minimize those mistakes. So that's the lineup, Tim. And finally, as always, I invite you to sign up for my free monthly electronic newsletter if you haven't already done so, either by going to savvyaviator.com and clicking on the thing that said you want to sign up, or during the post-webinar survey that Tim's going to put up right within the next couple minutes. I think there's a checkbox on there that you can check if you'd like to subscribe to the monthly e-newsletter. And finally, check out my book called Manifesto. It's all about maintenance philosophy on Amazon. Just go to Amazon and search for Mike Bush Manifesto, and it'll take you right to it. So that's all I have, Tim, and I guess we'll see everybody next month.
Fantastic. Thank you so much, Mike, for taking your time for preparing these presentations and sharing them with us and helping to educate us so we can be better aircraft owners and maintainers. Thank you so much. You have given us so much and continue to give us so much in this area. We just, words can't express my thanks to you for that on behalf of all the attendees, all the hundreds and hundreds of people who tune in to watch and learn and listen and be entertained. So thank you so much. You have a great night, my friend.
My pleasure, Tim. I promise the next couple won't be quite as geeky as this one, too.
Well, geeky's not so bad. It was a good presentation. It was one of your better ones, actually. I really enjoyed it.
Thank you. But then you're a known geek, you know.
As are hundreds others that tuned in, too. Thank you all so much for tuning in tonight, everybody. Have a great night.